Hello, dear students. This is Ikhlaq sir. I am back with another important example in Newton's laws of motion, and that is the motion of connected blocks. A very important topic. Okay. Now let's straight away switch to the example number one. So see that there are two blocks. This block is M1, and this another block that is M2. The two blocks are connected with the help of this string, and an external force F is applied on the block M2, which in turn pulls the block M1, and both the blocks will move towards, they will accelerate towards right with some acceleration A, isn't it? And what we are supposed to calculate is that we have to calculate, number one is the acceleration of the system, and number second is that the tension in the string. Okay, first and foremost, we'll do the proper physics. We'll apply proper physics, and then we'll try to calculate what's the acceleration of the system, number one, and number second is that we'll try to calculate the tension string. Okay, then I have a pro tip for you in order to calculate tension string. Okay, so see that these are two blocks M1 M2 and the external force is F. Now we want to calculate acceleration, so simply we will do one thing, that is apply Newton's second law. And what's that? Acceleration equals to net force or sum of all forces divided by the total mass of the system. Okay, in this very system, the external force is only one, and that is this capital F. All right, the other forces, they will cancel in pairs, which means that the net force is equal to F. And what is the total mass of the system? That's obviously M1 plus M2. So this is the acceleration of the system of both the blocks. Now since that these two blocks are connected, this block and this block, they are connected with the help of this string, as a result of which the acceleration of both the blocks will be same, and that comes out to be this F divided by M1 plus M2. I hope that it's clear to you. Next, what I'm going to do is that we will have to calculate the tension string. Okay, the tension string is, that is T. I can show it like this, or I can show it like this as well. So this is the tension in the string, and we will have to calculate what is this tension in the string. Now how to calculate tension in the string? What to do for that? Simply, I will try to construct a free body diagram for one of the two blocks, either for the M1 or for the M2. I will construct free body diagram. Better is that we'll construct the free body diagram for the M1. So let's try to do that. So this is our block, which is M1. All right, and there is the force on this M1, which is the tension in the string. There are two more forces on this M1. One is normal direction, the upward direction. Another is weight in the downward direction. They will cancel each other. Okay, so that means the net force on this M1 will be simply tension in the string. All right, now I will apply Newton's second law. And what is that Newton's second law? That is force equals to mass into acceleration. Okay, now what's the net force on this block? That is T. What's the mass of this block? That is M1. Multiplied by what? Multiplied by A, and we have just calculated the value of this A, that is this, which is F divided by M1 plus M2. So this expression gives me what? It gives me the tension string. So this is the tension string. This is the tension string. Okay, now I am more interested in calculating tension string. The reason is that जब भी ये क्वेश्चन पूछा जाएगा नीट में या JEE मेंस में, you will be supposed to calculate tension string and not the acceleration. Okay, so what I am trying to do here is that I will try to find a shortcut technique to calculate, a shortcut trick to calculate the tension string directly without calculating the acceleration. All right, let's try to do that. So here is a pro tip for calculating tension. To calculate T, to calculate tension string. All right, and what's that? That's like this. See that यहाँ पे जो हमें टेंशन निकला, that is M1 multiplied by F divided by M1 plus M2. Okay, so what is this M1? M1 is that mass which is away from this capital F, isn't it? this m2 is closer to the F and m1 is away from the F. M1 is away from the F. Divide by total mass, which is m1 plus m2, multiplied by the external force, which is F. Okay, so that is how I can calculate the tension string directly. So let me write down here. The tension string will be equal to, it is equal to mass away from capital F, away from capital F, divided by the total mass, that means the summation of all the masses, multiplied by what? Multiplied by the external force, which is F. Okay, so this is the shortcut trick to calculate tension without calculating the acceleration of the system. Okay, let's try to apply this trick. Let's see whether it works or not. So here we have example number 2. See that in the example number 2, we have two blocks. One has a mass of 6 kg, another has a mass of 4 kg. The tension in the string is equal to T, and we are supposed to calculate that tension in the string. Okay, I'm not interested in calculating acceleration because that will not be asked in the competitive exams, because it's very easy to calculate the acceleration. Okay, now you tell me there are two blocks, one is 6 kg, another block is 4 kg. Which block is away from this external force, which is 20 Newton? Which block is away from this? Is it 4 kg or is it 6 kg? Obviously, the mass away is this 6 kg. Okay, so let me use the trick, that is tension is equal to, it equals to mass away. And what's that mass away? That is 6, divided by total mass. Total mass is 6 plus 4, which is 10, and external force is 20. All right, this 10 and 10 will cancel. 6 2s are 12. So tension nikla 12 Newton. So this is the answer to this question, 12 Newton. Okay, so that means with the help of this trick, we can directly calculate tension without calculating the acceleration of the system. In one line, we can say what the tension in the string is. If you are interested in acceleration, no doubt we can calculate that. Acceleration will be simply equal to the external force, which is F, divided by the total mass of the system, isn't it? Now, what is the external force on the system? That is 20, divided by what is the net mass of the system? That is 6 plus 4, which is 10. 20 divided by 10 is 2 meter per second square. For the sake of curiosity, we have calculated acceleration. Otherwise, it is not required. Because this question, if this question is asked in NEET and JEE, the question will be like this: calculate tension in the string. Okay, let's do one more example in here. So this is our example number 3, and see that this example number 3 has been asked in JEE Man 2024. In this question, we are supposed to calculate tension T1 and tension T2. Let's apply the same trick. And what is that trick? That is tension equals to mass away from capital F, mass away from the external force, divided by the total mass of the system, into what? Into the external force, which is F. Okay, so let's try to do that. We are interested in calculating T1. Okay, and we have to calculate T2 as well. Okay, so T1 will be something like this. Let me write it here. This is T1 multiplied the external force. Okay, now for T1, for this string, can you tell me what is the mass away from the F? That is this 5 kg, isn't it? For this tension, for this string, the mass away is this 5 kg. Okay, is that clear to you or not? So what I'm going to write down is this is 5 kg divided by, what's the total mass? Total mass is 5 plus 3 is equal to 8. 8 plus 2 is equal to 10. This is 5 plus 3 is 8. 8 plus 2 is equal to what? That is equal to 10. So divided by total mass, that is 10. Into external force. Now see that the external force is this 80 Newton. So let me write down here 80 Newton. Okay, this 0 is going to cancel. 5 into 8 is 40 Newton. So the answer comes out to be 40 Newton. So this is the answer to this question, and we have calculated T1. Next, we are supposed to calculate T2. Easily we can calculate T2 also. So T2 will be something like this. T2 will be something like this. Now you tell me what is for this T2. देख ले बेटा, दिस द स्ट्रिंग, ये हमारे पास एक स्ट्रिंग है जिसमें हमें टेंशन कैलकुलेट करना है. ठीक है जी. Now what is the mass away from the capital F. This is the capital F, and what's mass away? The mass away is this total mass, this one, which is 5 plus 3 is equal to 8. And the total mass is obviously 10, and the external force is 80. Okay, so the mass away is this 5 plus 3. Total mass is 10. Let me write down here 10. And the external force is equal to what? That's equal to 80. This and this will disappear. So tension T2 comes out to be 5 plus 3 is 8. 8 into 8 is 64 Newton. So easily we have calculated T1 and T2, that too without calculating the acceleration, and that too without constructing a separate free body diagram for this 5 kg and for this 3 kg or 2 kg. Okay, directly we have applied this trick. So this trick is very important. It's a handy trick to calculate tension directly without calculating what? Without calculating the acceleration and without constructing a free body diagram, a separate free body diagram. Thereby it saves a lot of time. Okay, so next we have one more question on this variety. Let's try to do that. See that this is example number 4. Example number 4 is that there are two blocks. One block is block A and another block is block B. Okay, mass of the block A is given to us, that is 7 kg. Mass of the block B is given, that's equal to 3 kg. Now in this very case, two forces, external force, are applied. One force is this 40 Newton and another force is this 20 Newton. And what we have to calculate is the tension in the string. The tension in the string, we have to calculate that. Okay, now how many forces are there? There are two forces. Will that trick still work? Yes, of course, that will still work. But you will have to take care of one thing, that is there are two external forces. Okay, so let me write down that the tension is equal to mass away. It is equal to mass away divided by external mass divided by total mass, divided by total mass into external force. Okay, now how many external forces are there? Obviously there are two forces. One external force is 40 and the total mass is 7 plus 3 is equal to 10, plus another external force is there. And what is it? Another external force. Another external force is this 20 Newton and the total mass is 10. All right, is that clear to you? Is that clear to you? This is 40 Newton. For this 40 Newton, the mass away is 7 kg. Okay, this is 20 Newton, and for this 20 Newton, the mass away is 3 kg. So that's what I'm going to write down. For 40 kg, the mass away is 7. And for 20 Newton, the mass away is 3 kg. Now, try to solve this equation, you will get the answer. This and this cancels. 7 for 28. This and this cancels. 3 to 6. 28 plus 6 comes out to be what? It comes out to be 34 Newton. So the answer to this question is simply what? It is 34 Newton will be the tension in the string. Okay, simply what I have done here is that I have applied superposition principle. Superposition principle implies that first of all, see what is the tension due to this 40 Newton, number one, and number second is that what is the tension due to this 20 Newton. Then simply add those two effects, you will get the net tension, that is equal to 34 Newton. Okay, is this clear? Now let's move to one more example, a bit complicated example. Have a look. This is our final example in this, that is the motion of the connected blocks. So in this example, we are supposed to calculate tension T1 and tension T2. Again, see that there are two external forces. One force we have 80 Newton and another force we have 30 Newton. We are supposed to calculate tension in this string, number one, and number second is that we have to calculate tension in this string, that is T1 and T2. The procedure is exactly same, but take care of one thing, that is there are two external forces. So T1 equals to something like this. What is the total mass of the system? That is 2 plus 3 plus 5, that is 10 kg. And one external force is 30 Newton plus total mass is 10 kg. Another external force is what? That is 80 Newton. Okay, now have a look. We are supposed to calculate this tension T1, isn't it? For this 30 Newton, what is the mass away? The mass away is this 3 plus 5. What is the mass away? That is 3 plus 5. So here I have written it is 3 plus 5. Okay, then Again, we have to calculate tension T1, and this 80 Newton is the external force. For this 80 Newton, the mass away is 2 kg. That is what I am going to write down here. So this is 2 kg. This and this will cancel. 3 plus 5 equals to 8. 8 into 3 is 24, plus this and this will cancel. 2 into 8 is 16. 24 plus 16 comes out to be exactly what? 40 Newton. So this is tension in the first string, that is tension T1. Okay, exactly in the same way we will try to calculate what is tension T2. What is tension T2? We have calculated tension T1. Now next I am going to calculate tension T2. Again, there are two external forces. What is the total mass of the system? That is 10. What's one external force? That is 30. Plus, what is the total mass of the system? That is 10. What is the external force? That is 80. Okay. Now we have to calculate the tension in the string second. That is T2 we have to calculate. This is 30 Newton external force. In this string, we have to calculate tension. This is the external force. So the mass away will be this 5 kg. Isn't it? So let me write down here. It is 5 kg. Okay. Okay. Now have a look. Again, we have to calculate tension T2 due to this 80 Newton. So for this 80 Newton, the mass away is this total mass, which is 2 plus 3. So that's what I'm going to write down here. 2 plus 3. This 0 and this 0 will disappear. 5 into 3 is 15, plus this 0 and this 0 will cancel. 2 plus 3 is 5. 5 into 8 is 40. 40 plus 15 is what? It is 55 Newton. So the tension in the string T2 is what? That is 55 Newton. Okay. So we have calculated both tension T1 and tension T2. So there's a trick which always works. And what is that? What is that trick? What is that trick? Let's remind that again. Let's revise that again. Tension is equal to what? That is mass away divided by the total mass into external force. This trick always works. Okay, and it's very handy, because if you are able to apply this trick, you are not required to calculate the acceleration, number one. Number second is that you are not supposed to, you can bypass construct the free body diagram of any block. Okay, I'm sure that these 5 examples are crystal clear to you. These 5 examples are based on the same concept, that is the motion of connected blocks. And for every problem in NLM, there's a shortcut trick. There's a proper physics technique, and then there's a shortcut trick to do the same question in the least amount of time. See you next time with one more beautiful problem in NLM.